Okay, in this problem, there's a claim that's been made about, on average, how much time per month do U.S. mobile phone subscribers watch videos on their phone. And there's a claim that we want to test whether the U.S. college student population average is different from the reported overall U.S. average. Okay, so to do that, we have to write down our hypotheses. Our null hypothesis just says that the mean number of hours that all college students watch videos on their mobile phone per month is no different, so is equal to the number given by Nielsen for the general public, 3.7. The alternative hypothesis is we want to show there's a difference, so mu does not equal 3.7. Okay, since the claim is about a population mean, our point estimate is a sample mean, which is just the average of these values, which StatCrunch will calculate for you. Turns out to be 6.75. And the standard error, as we saw with the confidence interval, is just a sample standard deviation over the square root of the sample size, which is 8 in this case. So that turns out to be 3.88 roughly over the square root of 8, which is 1.3726. So your t-test statistic, we're going to try and assess or measure how far away is your sample mean from the claimed population mean. So to determine closeness, we use a test statistic to do that. Okay, so we'll calculate the difference to begin with in the numerator. So we'll take x bar minus our claim value of mean, and then we'll divide by the standard error. Okay, so let's see what we get. X bar is 6.75 minus 3.7 divided by 1.3726. Turns out you get 2.22. So what this is saying, just take a minute and think about this. This is saying that if it's really true that college students spend on average 3.7 hours a week watching videos on their phones, it would be very unlikely, right, that if you took a sample of 8 students that you would find that this sample spends 6.75 hours per week. Okay, this value is 2 standard deviations, more than 2 standard deviations away. Okay, so if you just draw a little t-table, standard t-table, so centered at 0, and then mark your standard deviation. So 2.22 is out here. Okay, and what we're going to be interested doing now is to find the p-value. And again, the p-value is how unlikely is it that we would get a sample mean of what we observed or more different given that the null hypothesis is actually true. Okay, since our alternative hypothesis is a two-tail test, we're going to have to find the area under the t-curve for the upper tail and the lower tail. So I'll shade those areas for you. So I'm looking for this, and then I'm also looking if I'm the same number of standard deviations below the mean, I want to find the area of the lower tail as well. Okay, so with the t-table, it's really easy to find those green shaded areas, what we call the p-value. Just go to your degrees of freedom, which are 7 in this case, sample size -1, and then go across this row until you see approximately your calculated value of 2.22. So hopefully you can see that the value 2.22 is right between those two values here. So in other words, the upper tail probability is between 2.5%. Okay? And because this graph is symmetric, we also know that the area of the lower green tail is between 2.5% and 5%. So the overall p-value we get by adding those values. So the p-value, and it's only an approximation, is between, 5% and 10%. Again, just adding the two areas of those green curves. Okay, so we'll interpret that in a minute, but let's go ahead and see how to do this with StatCrunch before we do the interpretation. So if you go into StatCrunch and click Stat, T-stats, one sample, and then with data, after, of course, entering the 8 data values into a column, if you run the hypothesis test, what you should get is this output. And again, there are screenshots in the lesson notes that show you how to use StatCrunch to do this. But the important idea here is you'll see you get your sample mean, your sample standard deviation, degrees of freedom, the t-test statistic that we computed above, and the p-value turns out to be exactly 0.0617, but just notice that value is in the range that we said it would be. Okay, so that's your p-value. Now we just want to state our conclusions. So should we reject the null hypothesis at the 5% level? Absolutely not. Okay, your p-value is greater than your level of significance, so we do not reject the null hypothesis. So let's just do the conclusions. We'll say something like this: there is not evidence, okay, that the mean number of hours per month that all college students who are mobile subscribers watch videos differs from the general population of US mobile subscribers. Okay, that's it.